Hey AP Stats, how you doing? Today we're going to start a new section, actually a whole new unit in AP Statistics, and we're going to be looking at two-dimensional data. You can think of this as an X variable and a Y variable, because that's exactly what we're going to do. We're going to start plotting things, and this is going to be how two quantitative variables are related to each other. So let's get started with our section 3.1, day 1. We have how many rubber bands should be attached to a Barbie so that she has absolutely the most fun without smashing her head if she were to jump from the balcony of the front foyer of the school, about 5.3 meters to the ground. So here's the catch. You can only use 7 rubber bands to figure this out. Now, if we were in class, this would be one of those things where I would give you 7 rubber bands and you would try to figure out how far would the Barbie stretch after 1 rubber band, 2 rubber bands, 3 rubber bands, etc. What that's going to look like once we do the bungee is this. Ready? 3, 2, 1, bungee! Oh.
They're kind of mild.
So we would use this first day to do a mini bungee. Now obviously, or maybe not obviously, you can't really do that here. So what I'm going to do is I'm going to put some data together from some past classes. Now, I'm sorry to deprive you of this, but we have to do what we have to do. So this is our data. With 0 rubber bands, obviously the Barbie is going to drop 0 centimeters. After adding 1 rubber band, we'll get our Barbie to drop about 5.3 centimeters. After 2 rubber bands, 10.7 centimeters. 4 rubber bands, 21.6 centimeters. And finally, with the last rubber band, with 7 rubber bands, our Barbie dropped 39.4 centimeters. Question 1 here is to identify the explanatory and the response variables. Well, what is the explanatory variable? The explanatory variable is used to predict and would be synonymous with the input. So that would mean the response variable. That's going to be the outcome of the study, or what we would call the output. So with a little bit of study here, you could probably guess that the number of rubber bands would be the explanatory variable, and the distance traveled by the Barbie, or the distance of that drop, that would be the response variable. Question 2, how many variables do we have? Obviously there are 2. And are they categorical or quantitative? Since we're looking at numbers here for the input and numbers here also for the output, we're really looking at 2 quantitative variables. Okay, the next thing over here is to use Staplet to create the scatter plot. And we've done Staplet in class a few times. Obviously, you could use your TI-84 also, but I think for this purposes, we'll use Staplet. This gives us something that looks pretty darn linear to me. That looks like a straight line almost exactly. So when we go to describe the relationship displayed by the scatter plot, we definitely need to say something about the linearity of this plot. Now, when we go to describe the relationship between 2 quantitative variables, we use direction, positive or negative slope, basically, unusual features, which would be outliers in either the X or the Y direction. Next would be form, and that's linear or nonlinear, which would be a curve. And lastly, with strength, we would usually say either it's a strong, moderate, or weak relationship. Now, how do you remember all 4 of these? Well, take a look at the letters for each one. This is another acronym, D, U, F, and S. That spells duffs. I don't know what a duff is, but it does spell duffs. So this is how a lot of people memorize it. So what is this relationship? we have positive direction, no outliers, a linear form, and strong strength. And I say strong because we can really see the line here. We don't have to use our imagination to see that line very much. We would say our scatter plot shows a strong, positive, linear pattern with no outliers or unusual features, with all the aspects of Duff's kind of underlined here for you, so you know exactly what we were looking at to begin with. So that's how we describe the relationship, and that really brings us to the end of this section. That's all we needed to do, was talk about how things are, how we describe and what we look at, and some of the, well, especially the learning target here for the first one is vocabulary. So what are some of the vocabularies that we learned? Well, we learned the explanatory variable was something used to predict, quantitative variable used to predict. We also learned that the response variable was the quantitative variable, which tells you the outcome of, and it responds to the explanatory variable. In our case, the distance traveled by the Barbie responds to or is affected by the number of rubber bands we used. We also talked about describing the relationships. We talked about Duff's, D-U-F-S. And then we looked at the scatter plot, how to make a scatter plot. A few things to note is we have a response variable and an explanatory variable on the x-axis and the y-axis. And we just plot this like we were in Algebra 1. So that's all we really needed to do today. Pretty easy, I think. Let's check our understanding down here. Is there a relationship between the amount of sugar and the number of calories in movie theater candy? Here is a sample of 12 different types of candy. We've got Butterfinger Minis, sugar and calories, Junior Mints, sugar and calories. So let's identify the explanatory and response variable, and we will also explain our reasoning. So what do we think? Do the number of calories depend on sugar, or do the amount of sugars depend on how many calories we have? And if we think about this a little bit, sugar is the explanatory variable, calories are the response variable. If sugar is added, the number of calories is going to increase. So that tells us that the calories are responding to the amount of sugar added to the candy. Let's make a scatter plot to display the relationship between the amount of sugar and the number of calories in movie theater candy. Again, we're going to use our Staplet, or you might want to use your TI-84. Here we have our TI-84, and we're going to push Stat Edit, which is the same menu that we used in chapters 1 and 2, and we're just going to put our sugar amounts in list 1. So we have 45, I think the next one is 107, then we have 62 and 44, etc. And then we want to scroll over to list 2, and we're going to put in the number of calories, so 450, 570, etc., etc. And once we have our calories and sugar in list 1, we're going to go back to the home screen, and then we're going to push second y equals to get to that stat plot menu. I'm sure you're familiar with that. I notice that stat plot 1 is already on, so I'll go over to it, and we'll create the scatter plot, which is that very first plot. Now you notice that when I clicked over to it, the options changed here. I now have L1 in the X list. If you have another list with the X list, you go ahead and put that, remembering that X list is synonymous with explanatory variable. Y list, I put my Y variables in L2, or this is the response list. We're going to put our mark, and we're going to change color. Orange, I don't quite, it's a little hard to read orange. I don't want to go with black. I'm thinking green might be the way to go. Yeah, let's go with green. What the heck. And then we'll just change this to, we'll plot this with zoom and then zoom statistics, number 9. That should give me a nice scatter plot. All right, here's our scatter plot. Definitely not as clean looking as our scatter plot for the Barbie information, but there's still a positive trend here. We can still see how as the number of sugars increases, the number of calories also increases. So this still looks like a positive relationship. When you put this on your paper, don't forget that you still need to label the X and Y axes. Let's describe this relationship with using Duff's. So our scatter plot relating calories to sugar in movie theater popcorn or candy. We are always relating the response variable to the explanatory variable, shows a strong, positive, linear relationship. Let's talk a little bit about outliers. Is there anything here that is not following the pattern? And I would say this guy right up here, that doesn't seem to follow the pattern. For the amount of sugar it has way too many calories. So which one is that has too many calories for the amount of sugar? And that seems like it's probably these junior mints right over here. 570 for 107? No, that's not it. Let's see. Oh, you know what? We can take a look at that using our TI. Let's grab our TI calculator. We'll push trace, and you'll notice here how the cursor is on. If I push left and right, it scrolls to each of the different candies. So this one right here has 79 grams of sugar and 790 calories. Which one is 70 and 790? 70 and 7, oh, right here, the peanut M&Ms. That seems to be our outlier. So the peanut M&Ms is an outlier in the Y direction. It has more calories than expected for its sugar content. And that, my friends, is where we're going to stop for today. Beginning look at the scatter plots and linear relationships relating two quantitative variables together. We'll see you next time here for more statistics. Bye for now.